Waves carry energy, and in the case of earthquake waves, they carry huge amounts of energy. The first thing you feel when an earthquake hits is a longitudinal wave, and every sound you hear is a longitudinal wave. Waves are everywhere in nature, and understanding them is an important part of explaining the world as a whole. Longitudinal waves, also known as compression waves, when describing waves in mechanical terms, are waves where the vibration is parallel to the direction the wave is moving. That might be hard to picture, which is why we need some help from a slinky. It looks something like this. A longitudinal wave is what you get if you push a slinky along its length, sending a pulse down it. The other type of wave is called a transverse wave. A transverse wave looks something like this. A transverse wave is a wave where the vibration is at right angles to the direction the wave is moving. That's what you get if you move the slinky from side to side, sending a wave along it. There are a few features we can label on a longitudinal wave, as shown in the diagram on screen now. A compression is the part of the wave or slinky that is pressed together. This is like the crest or peak of the wave. A rarefaction wave is the part of the wave or slinky that is the most spread apart. This is like the trough of the wave. You can see how these compressions and rarefactions can be considered as crests and troughs if we plot a graph of particle density against position for a longitudinal sound wave on screen now. As you can see from the diagram, the particle density varies in a perfect wave shape. This is how we know that longitudinal waves are really waves. This diagram allows us to measure another feature of longitudinal waves, the wavelength. A wavelength is the distance from two similar parts of a wave, from a peak to the next peak, or from a trough to the next trough. It is the length of one full wave, one full oscillation. Wherever you measure it, the number should come out the same. Most waves in the universe turn out to be transverse waves, but there are a few examples of longitudinal waves. The first wave you feel when an earthquake hits is a longitudinal wave. This is called the primary wave, or P wave. Although the P wave is the fastest earthquake wave, it causes the least damage, precisely because it is a longitudinal wave. If the ground is shook up and down or side to side, like a longitudinal wave, there tends to be less damage than if the ground is waving around like a transverse wave. Every sound we hear also gets to us in the form of a longitudinal wave. When your sister shouts at you from across the room, her vocal cords are vibrating the particles in the air, and these particles in turn hit other particles, on and on, until they reach your eardrum. Once your eardrum starts vibrating, your brain can hear the sound. Compression waves are waves where the vibration is parallel to the direction of motion. The term compression wave is usually reserved for use as a mechanical term, while longitudinal wave is much more common for what we're talking about. Such waves have certain features like compressions, the part of the wave that is pressed together. This is like the crest or peak of the wave. Rarefactions, the part of the wave that is the most spread apart. This is like the trough of the wave. And wavelengths, the distance from two similar parts of a wave, from a peak to the next peak, or from a trough to the next trough. Examples of transverse waves include the first and least damaging wave, the P wave, that hits when an earthquake happens, and every sound that passes through the air. Although longitudinal waves might not be as common as transverse waves, which are waves where the vibration is at right angles to the direction the wave is moving, we experience them every day of our lives. Understanding them is a key part of explaining how the universe works, and if we can play with slinkies at the same time, all the better.